Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to calculate confidence intervals for proportions using StatCrunch. Let's get started. To demonstrate how we're doing this in StatCrunch, first let's look at an example problem which will start by solving the old school way, and then I'll show you how to do it in StatCrunch. You'll see how much easier it is to get the same answer. So in this example problem, we have a candy company who wants to know if customers would be interested in purchasing a new flavor combination. And so they conducted a poll on their website. And it turns out that 73% of 23,854 visitors said they would be interested in trying a new flavor combination. The question we're asked is, what is the 95% confidence interval estimate of the population proportion? So to solve this the old school way, first we would recognize that we have a sample proportion of 73%. That means our probability of failure, if you will, is going to be 27%. Our critical value z-score is 1.96 because we have a 95% confidence interval estimate. 95% is our confidence level. So if we put that into StatCrunch, we see that for our two-tailed normal distribution, our two-tailed critical region, our critical values are plus or minus 1.96. For purposes of calculation, though, we're just going to take the positive value. Then we calculate our margin of error, which comes out when we substitute the values that we have into our equation. Calculated that out, 0.0056. So now we have everything we need to calculate our margin of error. So here's our general form for our margin of error. We substitute in what we know. 0.73 is our point estimate, and our margin of error, 0.0056. So we subtract those two numbers on the left, add them together on the right. That gives us an upper and lower limit for our confidence interval, 0.7244 and 0.7356. Now let's check out how to get those same numbers out of StatCrunch. So here we go. Okay, we're here in StatCrunch, and I'm going to show you how to work the problem we just looked at in StatCrunch. So to find my confidence interval in proportions, first thing I'm going to do is come up here and I'm going to click on Stat. And then I'm going to come down here and click on Proportion Stats, because I'm looking for confidence interval in proportions. One sample, because I have just the one sample. With summary, because I don't have any actual data. Here in the options window, I'm going to need to provide the number of successes and the number of observations. So we know that there's 73% of 23,854 that we would classify as a quote-unquote success. So I have to put the actual number in. So I'm going to get my calculator out. I'm going to put 73% times that total number they gave us, 23,854. And that gives me this number here, which I'm going to round up because I want to capture that partial person right here. So that's going to be 17,414. And then the total number was 23,854. And I'm looking for a confidence interval, so I want to click this radio button here with a 95% confidence level. That's the default. That's what I want. So I come down here and hit compute. And notice we get the same values here for our lower and upper limit in our results window that we got previously using the old school method. So that's really all there is to it. Hope that helped you. Okay, so going back to the problem that we have here, we see that we get the same lower and upper limit using StatCrunch that we did with the old school method. Now, we're asked one final question, and that is, does the confidence interval provide a good estimate of the population proportion? So you see you've got 4 answer choices to choose from here. I'm going to give you a moment to read that over and select the answer that you think is the correct one. And then after that little pause, I'm going to come back and we're going to talk about what the right answer is. Okay, I hope you made your selection, and I hope it's the right one. The right one is going to be answer option C. Answer option A is tempting because we do have a fairly large sample size here. So it is, tempting to select that. But in order to know that the sample's large enough to provide a good estimate for the population proportion, you have to run through the sample size calculation, which we haven't gotten to yet, and so that can't be the right answer. Answer option B, all the assumptions for confidence interval are satisfied. Well, what were the assumptions for the confidence interval? I mean, you've got to have the conditions for the binomial distribution satisfied, and it looks like we have those conditions satisfied. You've also got to have simple random samples, which we may or may not have. Actually, we probably don't have simple random samples because if you look at the next answer option, which is the correct one, we're looking at a voluntary sample. And that's exactly what you get with a website poll. Oftentimes when I'm visiting a website and I get asked to participate in a poll, I just click on that little X in the upper right corner or the little box that says no thank you, not interested, because I don't come to a website to participate in a poll. I come to a website to do, whatever it is the website has to offer. That's why I'm there. I'm not there for participate in a poll. So you can see this is a voluntary sample, and so that makes answer option C the correct answer. We wouldn't select answer option D because the responses are independent. If the responses were not independent, then, that's one of the assumptions that we have to have for the binomial distribution to be satisfied. And those assumptions were satisfied. So that's not really what we're looking at here. Answer option C is going to be the correct choice here. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.